This lesson is going to be about percentage yield. And percentage yield is looking at a chemical reaction and how much product it produces in theory, and then comparing that to how much product it actually produces in real life when you go into the lab. So we are going to start with a chemical equation where we have hydrogen and carbon monoxide reacting together to make CH3OH, which is another form of methanol. And we are told that when we did this experiment in the lab, that you got 3.57 times 10 to the fourth grams of methanol, CH3OH. Okay, so this is what we actually got in the lab. We call this actual yield. Okay, so this is in reality, when doing this experiment, this is how much we got. And we got this quantity based on these, this amount of reactant we put in. So we put in 6.85 times 10 to the fourth grams of carbon monoxide, and we put 8.60 times 10 to the third grams of hydrogen. So that's what we put in. This is what we got out of the reaction. So let's see how that compares to theoretically how much we should get. And so to start off with, we're going to do what we've always been doing, is we need to figure out how much methanol can be made, and we need to figure out what our limiting reactant is. So with that said, we need to change things into moles, and by doing that, we know that you have 28.01 grams of carbon monoxide for every 1 mole of carbon monoxide, which works out to be 2.45 times 10 to the third moles of carbon dioxide. And for our hydrogen, keep in mind it's H2, so that means we need to have 2.02 grams of H2 for every 1 mole of H2, and that works out to be 4.27 times 10 to the third moles of H2. Okay, so now looking at this, when I look up at my equation, I know there's a 2-to-1 ratio. So I need to have double the amount of hydrogen than I need carbon monoxide. So does that work out? Do I have double the amount? Well, looking at this quantity, I sort of go, okay, I need to have double this. Is that double that? And you'd say, no, it isn't. But let me show you how that works just as a review for when we do it using dimensional analysis. So I could take any of those numbers that we just solved in moles. So 2.45 times 10 to the third moles of CO. And to figure out how many moles of H2 I need, I know I have a 2-to-1 ratio. For every 1 mole of CO, I need to have 2 moles of hydrogen, which works out to be 4.90 times 10 to the third moles of hydrogen. Do I have that quantity? I look up here and I go, nope, I do not have enough. So for that reason, this here is my limiting reactant. So nothing new. We've been doing this before. Okay. So now, based on that, if I have 4.127 times 10 to the third moles of H2, how many moles of methanol, or CH3OH, does it make? And I know that for every 2 moles of H2, 1 mole of CH3OH is produced. And that works out to be, let me get the calculation, 2.14 times 10 to the third moles of CH3OH. So next question is, how many grams does that work out to be? Well, then the last calculation is making those moles into grams. So I take my moles of CH3OH and multiply them by the molar mass. So 1 mole of CH3OH is equal to 32.04 grams of C3OH, which works out to be 6.86 times 10 to the fourth grams of CH3OH. That means this is what quantity theoretically I should have had, and we call this the theoretical yield. Okay, so meaning when you do the calculation, how much should you get of a product based on theory? So you notice that here I have 6.86 times 10 to the fourth grams of methanol, but in reality, how much did I really get? I got almost half of that actually happening in the lab. Theoretically, I should have gotten this much, but in actuality, I got that much. So what percent yield did I get? In other words, how much of what percentage of what I expected did I actually get? So I take these two numbers, take this number and create it into a percentage. So I'm going to move on to the next slide. And just as a remember we had actual yield, and this one I gave to you, so this is a given of 3.57 times 10 to the fourth grams of CH3OH. My theoretical yield, what I would have expected to get had everything reacted, was 6.86 times 10 to the fourth grams of CH3OH. Okay? And what percentage of what I actually should have gotten did I get? And simply all you need to do is take actual yield over theoretical yield, and that gives me my percentage yield. In other words, 3.57 times 10 to the fourth grams of CH3OH over 6.86 times 10 to the fourth grams of CH3OH, and my percentage, of course I times this by 100% to get my percentage, and the percentage works out to be 52%. That means only 52% of the product actually formed compared to what I expected, and that's your percentage yield.